So in this video, we'll talk about security in current applications that is used in e-payment systems. So first we'll see about cardholder present e-transactions. So cardholder present e-transactions means the cardholder will be physically present at the transaction site. So he will be present with credit card. So that means an example is that you are going to a shop and you are paying using the credit card. So you are physically present there, and there will be a terminal will be there. So in the terminal you will be sweeping your card. So here this will be considered as a cardholder present e-transactions. And you are familiar with the operations that is happening there. So there will be a magnetic strip, and that is read by the point of sale. That's a terminal, and this terminal is online with the bank card network. So that will be connected to the internet. So the connectivity to the issuer bank provides real-time payment authorization. So the checking whether the enough balance is available and whether it is a genuine card. So all those will be verified at real time. Now if authorization is successful, a receipt is generated, and the receipt will contain the amount of transaction, etc., etc. Then the magnetic strip contains the name of the account holder. Then there will be a credit card number, that is CC. Then there will be expiry date of the credit card. Then there will be a card verification value. So card verification value that you can see in the back of the card. It's a 3-digit number. And this type of transactions, that is cardholder present transactions, are more secure when compared to cardholder not present transactions. So cardholder not present transactions means you will be using your credit card online. So there the card holder is not physically present. But here also, that is attacks are still possible. So we'll see some of the attacks. One is cloned attack. So cloned attack means that is an attacker could skim another person's credit card. So skimming is, as you know, it's a process of reading the information of the magnetic strip of a card. So after skimming, you can create a clone of the skimmed card, and you can copy all the information from the skimmed card to the clone. So once it is done, then the attacker will be using your card for financial transactions. So this is cloned card attack. And next is lost or stolen cards. So this may happen. The attacker can steal the credit card, or sometimes your credit card will be lost, and that will reach the hands of an attacker. So then attacker could pose as a owner of a lost or stolen card. So this is second type of attack. And another type is spoofed terminals. So there is a fake terminal could be installed in a mall, which could harvest secrets stored in the cards of the users. You must have seen this on that is some of the movies, that is the spoof terminal attack. Now how do you prevent the use of lost or stolen cards? So there are one method is that you can signature verification can be performed. So that means in the credit card there will be the signature of the card holder. Now at the shop you will be merchant can ask the card holder to manually sign in the receipt. So you can verify both signatures. So the signature is there on the card, and the card holder has signed manually on the receipt. So these two signatures can be verified, and you can make sure that that is the card is actually the card of the card holder. But as you know, that is, it's easy to forge a signature. So attacker can put someone else's signature so that it will be difficult to verify. The second method is that proof of identity. So you can ask the card holder for some identity proof, Aadhaar card or election ID card or some ID card can be asked, and you can verify the identity of the person. So these are some of the methods that are used to prevent the use of say lost or stolen card. Now, to determine the authenticity of the card, so we can check the hologram and artwork on the card together with the expiry date and the credit card number. So each bank will be having, say, some logos or some other protective measures will be there in the card. So you can check for that. For example, SBI or the Federal Bank credit cards or debit cards will be having, say, certain logos or certain holograms, etc. will be there. So you can check whether all those are present in the card. So if they are not, some of them are not present, you can say that there is a duplicate card, or that is a skimmed card. But as you know, that some of the attackers will be very smart. So it will be a carefully cloned card will be very hard to detect. So it will be look alike of the standard credit cards or genuine credit cards. So it will be very difficult to detect the cloned card. Now next is chip card transactions. So chip card transactions, as we have seen before, the card will contain a process or a chip inside the card. So they are having a lot of features as well. And the main features are the way the card authentication and card holder verification are handled. So that is different from the memory cards. Memory cards means that is the cards without processes. So here it supports offline transactions also. So offline transaction means without connecting to the issuing bank. So offline transactions save network bandwidth and involve less computation. But there is an element of risk associated with an offline transaction. So banks may permit only a limited number of offline transactions with constraints on the maximum transaction amount. So that means maybe after at the end of the day, normally in offline transaction, the transactions will be recorded by the terminal, and maybe at the end of the day, this recorded transactions will be connected to the issuing bank. So it will not be it will be online only after a period of time, maybe at the end of the day, or maybe 4 hours, or maybe 6 hours, so that you can decide on that. So here you can see a record of each offline transaction is saved on the participating terminal. Now, one or more times a day, this terminal uploads to the issuer all the transactions it has conducted since the previous upload. So that is how this is done. So even though the net is down, you can do this offline transaction, but as we have seen before, there's a risk involved, because you are not, the balance amount in your account is not checked. So risk is involved. Sometimes the bank will not get the money. Now there are 3 steps involved in each say card based transactions. One is card authentication, and second is card holder verification, and third is actual transaction processing. So this is these are 3 steps. Now the main entities involved are, again, there will be a user, there is a owner of the card or card holder, and there will be the card itself. Then there will be a terminal on which the card will be saved, and there will be an issuer. Issuer will be issuing that will be a bank, and issuer will be issuing the card. Now, first step, we'll see these steps one by one, and first step is card authentication. So here in card authentication, the first step is that the issuer signed static data on C, that is card, is communicated to the T, that is the terminal. So issuer signed static data includes the PAN, this permanent account number, then expiry date of the card, then some of the verification methods that is permitted. So this static data will be sent from the card to the terminal. So the card C also sends the issuer certificate. So the issuer certificate will be from a third party. Now so this information will reach the terminal T, and T first validates the issuer certificate. Now after that, extracts ICE public key to verify ICE signature on the static data. So we have said that there is an issuer signed static data. So that means issuer is signing the static data. So your digital signature is used. So the issuer will be signing the static data using the private key of the issuer. So here, using the public key of the issuer, you can verify the signature. So for that, the public key, maybe the ICE certificate will contain the public key of I. So that will be extracted, and the signature will be verified. Now to detect clone cards, you can go for a dynamic authentication. So EVM supports this option. EVM means that is a name that is given to the chip card. So EVM actually comes from the names of 3 companies. That is Europay, E stands for Europay, and M stands for MasterCard, and V stands for Visa. So it is EVM. That is EVM. EVM, that is this chip card. So supports this option. And only requirement is that card should have an RSA public key, private key pair, and a certificate from the issuer. So that is the requirement. So That means a card will be involving in a encryption, asymmetric encryption. So public private key pair should be ready, and a certificate from the issuer. So maybe it will be digitally signed by the issuer. Certificate containing this data about the card or card holder will be signed by the issuer. Now, dynamic authentication involves these steps, that is terminal T generating a nonce and sending it to the card C. Now C signs the nonce and sends it to T. C is again card and T is terminal. So C also sends its certificate so that T can verify its signature on the nonce. So that means C's certificate will contain the public key of C, and C is signing the nonce using C's private key. So T can obviously verify the signature on the nonce using the public key of C, and the public key of the C will be in the certificate, and that is authenticated by the issuer bank. So that is happening in card authentication, and next step is card holder verification. So options for verifying that the person in possession of the card is also his legitimate owner include the following. One is requesting the owner to enter a PIN. So as we have seen before, you can request, or normally we are doing that. That is, they will request us to enter a PIN. 3-digit or normally 4-digit PIN will be entered. Second thing is that you can request the owner to manually sign the receipt so that you can verify the signature, or embedding a photograph of the owner on the card. So if it is a stolen card, you can see the photo will be different. If PIN option is used, then you will have to do these steps. That is, T prompts the user for the PIN. So terminal T encrypts the PIN with C's public key and sends it to C. So C decrypts the message and extracts the PIN and checks it with the stored PIN. So for verifying the PIN, so this is followed. So you ask the PIN, and so that will be given to that will be sent to that will be entered in the terminal. Terminal encrypts the PIN with the C's public key, and T knows C's public key because that is in the C certificate, and sends it to C. C will be decrypting the message and extracting the PIN, and it will compare whether the received PIN is same as the stored PIN. So that is performed in the second step, that is card holder verification. Third step is transaction processing. So here the actual data is being transferred. So since TD, that is transaction data. So sends transaction data from the terminal to the card. That is how many what is the amount of the transaction, that will be the transaction data. Or you can see that it includes the transaction data may include those things, that is the transaction amount and the currency in which transaction is happening, then date and time, then PAN, that is permanent account number, Then the terminal ID. So maybe different terminals will be there, ID of the terminal and announce. So this will be there in the transaction data. So that is sent from the terminal to the card. So C computes a keyed hash or MAC on this data, that is transaction data. Now for each transaction, the C computes a fresh MAC key. So that has to be noted. Key is a function of the long-term master secret. It shares with the issuer. So it is predefined. Now session key will be the function of an application transaction counter that is incremented for each of the new transaction. Now C sends the MAC and the application transaction counter to the terminal T, which forwards it to the issuer I together with the transactional data. So issuer I is responsible for authorizing the transaction. So issuer checks whether the transaction amount is within acceptable limits and other details, that is whether there is sufficient balance is available and some other details that is will be verified, or every other things are in order, that will be checked. Now it also derives a MAC key and proceeds to verify the MAC. Now if MAC verification succeeds, it computes another MAC on the MAC it just verified. So MAC is nothing but message authentication code. So after verification, if the verification is successful, the issuer will compute another message authentication code on the message authentication it just received or it just verified. Now this later MAC message authentication code is sent to the card via terminal T. Newly computed MAC is an indication to C that the issuer I has authorized the current transaction. Now the second MAC can be verified by C. Now, so this is the total what is happening. There are three steps. One is say card authentication, and second is encrypted pin transfer, that means card holder verification, and third is the transaction messages, that is the transactional data is being sent. So here you can see the three entities: the card user will be here, then the card terminal T, and the issuer.